had a lot of practice when it comes to evaluating trig functions of angles that are in radians, and now we're going to switch gears and focus more on angles that are in degrees. So the end of this, hopefully your goal is to be able to evaluate, for instance, the sine of 240 degrees without looking at your unit circle. And when we first started talking about this in in radians, I talked to you about how it was really just important to know that first quadrant. And if you were comfortable with the first quadrant, everything else could kind of build from that. So let's pretend we're looking at the first quadrant of the unit circle. We know right down the middle that's 45 degrees, and we should know, hopefully, that's equivalent to pi over 4, and we have come to terms with the fact that it is always root 2 over 2 anytime you're talking about radian measurement over 4. And we referred to those different denominators often when we were looking at radian measurements. You know, if I gave you this angle here, we said, oh yeah, that's pi over 6, and now we would refer to it as 30 degrees, but that would be root 3 over 2, 1/2. And anytime I gave you something over 6, like 11 pi over 6, you could reference this terminal point and use that to help you, and you would just know that you needed to adjust positives and negatives. We also know, obviously, up here, this was in radians, pi over 3. In degrees, we know it's 60 degrees, and that's 1/2 root 3 over 2. So if you can learn this, and you're okay with this, then figuring out something like the sine of 150 degrees, or the cotangent of 210 degrees, or anything like that, these are going to come a little bit more naturally after you can use a reference angle from that first quadrant to help you get to that. And here's what I mean by a reference angle. By definition, it's the acute angle. Think about acute, that means less than 90 degrees, so less than 90-degree angle, that's formed by the terminal side of that angle and the x-axis. So if I give you something like, let's look at this picture down here. Let's pretend that I am looking at 210 degrees. Let's say that that theta is 210 degrees. So maybe I'm actually asking for you to find the sine of 210 degrees. Well, 210 degrees is very close to the x-axis over here. In fact, it's so close right here, 210 minus 180, I know that that's 30 degrees. That angle right there, that acute angle formed by the terminal side and the x-axis is 30 degrees. What that means is I want to reference 30 degrees when I'm trying to figure out this answer. Because 30 degrees, I am very familiar with 30 degrees. I know that this has the terminal point root 3 over 2, 1/2. So if I can think about that, all I have to do is say now, oh, okay, I'm in the third quadrant, which means they are both going to be negative. So when I'm doing the sine of 210 degrees, it's going to be negative 1/2. But I was able to reference an angle that I was more comfortable with. Off the top of my head, I might not have it memorized what the terminal point of 210 degrees, but I do know 30 degrees is terminal point. How about something over here in the fourth quadrant? What if we did 315 degrees? So let's say that maybe in this case, theta was 315 degrees. Maybe I want to find the cotangent of 315 degrees. So that means all the way around is 315 degrees, but that means I am only how many degrees away from 360? Well, 360 minus 315, we have 45 degrees there. So that acute angle's measurement is 45 degrees. That means that 45 degrees is what we could reference, and we know that that's root 2 over 2, root 2 over 2. Now, being in the fourth quadrant, we're going to have a positive x and a negative y. Now, if I want to do the cotangent, it's going to be x over y, and it's something over itself, but a positive over a negative. That means our answer here is going to be negative 1. It's pretty straightforward when you're in that first quadrant. In the second quadrant, let's say if I wanted to find something like, let's say 120 degrees. Maybe I want the cosecant of 120 degrees. Well, what's my reference angle? Okay, well, this is where 120 degrees is. So how far away is that from 180 degrees? Well, that acute angle would be 60 degrees. So I should reference 60 degrees, which I know is going to be 1/2 root 3 over 2. But to be cosecant of 120 degrees, that's in the second quadrant, so my negative x positive y. And now the cosecant of 120, I can just do 2 over root 3, which then I would rationalize, and we should get 2 root 3 over 3. So it's fairly easy once you have it pictured. Sometimes it's a little bit more intense when I have something where, like for instance here, I just have these angles given to me. What I'm going to do is I first try to just pick out where they are. So I know that this is 0 degrees, this is 90, this is 180, this is 270, and again, you can think of this as 0 or 360. So if I'm trying to find, for instance, the sine of 240 degrees, first I just place it. I know 240 degrees is somewhere in quadrant 3. So if it's over here, this is the terminal side. That means I'm looking for this angle here between 240 degrees, right, and 180. So if I can do 240 minus 180, we know that that's 60 degrees. So that should be my reference angle. So this is what I'm going to reference. And I know 60 degrees because I've memorized that first quadrant really well. So I know that that's going to be 1/2 root 3 over 2. But the fact that I'm in the third quadrant, that means I'm going to have a negative 1/2 and a negative root 3 over 2. So the sine of 240 degrees should be negative root 3 over 2 for our final answer. 330 degrees. Again, where is it going to be? Well, it's between 270 and let's have this written as 360 for right now. So it's somewhere over here. So the acute angle is going to be between 360 and 330. So I can take 360 minus 330. I know that that acute angle then is going to be 30 degrees. So that means 30 degrees is now my reference. And since I'm very familiar with 30 degrees being root 3 over 2, 1/2, then I can apply that. Now I'm in the fourth quadrant, which means in this case a positive x and a negative y. So if I want the cotangent of 330 degrees, remember that that's going to be x over y. So we're going to do a positive root 3 over 2 over a negative 1/2, and we're going to end up with a negative root 3. So this would be our final answer for the cotangent of 330 degrees. Sometimes it gets a little bit trickier if your angles are outside of the 0 to 360 degrees range. You might have to first find a coterminal angle. So for example, on this one with 960 degrees, you're going to want to take away 360. And if you do it one time, you get to 600. You're going to have to take it away again. You get to 240 degrees. So if I take away 360 enough, I know that 240 degrees is coterminal. And now I'm going to use the exact same information that I used here. The fact that, again, 240 degrees is 60 degrees away from that x-axis. So even for 960, I'm going to reference 60 degrees, which means, again, that I'm looking at negative 1/2, negative root 3 over 2, because they're coterminal. I know it's in that third quadrant. And so the cosine of that would be the x-coordinate, so negative 1/2. And let's do one more. Anything that ends in 5, you should be thinking it's probably going to reference your 45 degrees, just because that's the only time that we ever see that actually happening. But first, let's find what 495 is coterminal with. So if we take 495 and subtract 360 degrees, we get 135 degrees. So again, we know they're coterminal, so the terminal sides of these angles will be in the same spot. So if I can look at 135 degrees, then we're okay. Well, 135 degrees is in the second quadrant, so we can picture it over here. So how far away is that from 180? Well, I could do 180 minus 135, and we get 45 degrees. So like I said, we should know that that would be a reference angle, but just to show you the actual math behind it. So we know that's root 2 over 2, root 2 over 2. Sorry, that kind of looks like a 3 there. But being in the second quadrant, that's a negative x and a positive y. The cosecant, though, is the reciprocal of y, so we would have 2 over root 2, which we would then rationalize and get 2 root 2 over 2. Those are going to cancel. Our final answer would